Hello everyone, this is Joel over here. So in this video, we will be solving a numerical from LeetCode, which is reverse integer, LeetCode number 7. And yeah, let's get solved this. And here they have given 3 test cases. Let's look at one by one. And in example 1, they have given integer which is like x is equal to 1 to 3. So after once it gets reverse, the output becomes just 3 to 1. So it's like general reverse algorithm which we know, and this can be solved easily. And in example 2, same way they have given an integer with negative symbol in the first, which is minus 1 to 3. And once it gets reversed, the negative symbol stays same, but the numbers alone got reversed over here, which is like 1 to 3 got reversed to 3 to 1. And this is simple, like while returning we have to return it into minus 1 into the integer. So whatever things it's like multiplied with minus 1, it becomes negative, right? So this condition is also quite easy. And the third thing is like x is equal to 1 to 0, and while returning, if you check, it returns 2 1 because 0 to 1, 0 doesn't has value, right? So while returning we have to return it as 2 1. And yeah, this is also easiest one. And they have also provided in the question that assume the environment does not allow you to store 64-bit integers, signed or unsigned, which means our integer is 4 bytes, right? If there is an integer value, example 10-digit value, it exceeds our integers rule, right, which is 4 bytes. So during those cases, it should return 0, not the reverse value of the numbers. So totally we have 3 test cases and 3 conditions over here. So let us implement those in our numerical. So here, first thing, I'm just checking whether the integer is in positive or in negative. Let's assign a variable called boolean sign equal to true. So boolean sign equal to true indicates our numerical is in a positive. So let's put an if condition. If x is an integer, right? So x is less than 0, then we will just change this sign to false. So once our sign variable is true, we are indicating it's a positive integer. If it's false, we are indicating into a negative integer. So once the sign has been updated, let us change this whole integer into positive first. So we have a function in math which is like x is equal to math dot absolute of x. So absolute in the sense it makes everything positive, right? So our normal absolute function from the mathematical. So we are just taking the x value and then we are just giving to absolute function and making it as positive and again storing it in the x itself. So once this has been done, and normal reverse logic we are gonna use over here, because we have made this x number into a very normal thing, right? So let's start a loop while we are going to traverse it till x is greater than 0. So now, previously in normal cases, we used to initialize the reverse as int reverse equal to 0 for finding the reverse, right? But in this case, we will be like, instead of int, we will be using as long. Because of this condition, assume the environment does not allow you to store 64-bit integers. So I'll just tell you why this data type is being used in later part of the video. Let's start the usual coding of a reverse thing. So reverse is equal to reverse into 10 plus x modulo 10, and x is equal to x by 10. So this condition is, I'll just explain you over here. I just copy this first. So now let's assume we have an integer value of x is equal to 12. Okay, and we have to reverse it to 21 over here. Okay, so we will just see the logic. So here we have reverse is equal to reverse into 10 and plus x modulo 10. Okay, so as a first part, our reverse variable is initialized with 0, right? So first we have reverse is equal to 0 and reverse is equal to, you have reverse into 10. So what is the value of reverse? It's 0, right? So 0 into 10 is 0 plus we have x modulo 10. So what is the value of x in our case? 12 modulo 10. So 12 modulo 10 will be equal to 2. How? Because anything is divided by 10 and taken those remainder will be the ones place of the number which is being divided. Example, in our case, if you divide 12 by 10 and if you check the remainder, it will be 2 because it's the last digit of our integer value. Let's go and check and see, like 12 modulo 10. So you can see 12 mod 10 is being 2 over here. So same way we are using over here. So now 0 plus 2, which is 0 plus 2 will be equal to 2 over here. So now we have stored this last digit in our reverse. So now our reverse got updated, right? So first step, our reverse was in 0, but now our reverse will be equal to 2. So we have successfully took the last ones part of our integer and we stored inside a reverse variable. Now we have to decrement the ones part from the main integer, which is x is equal to 12. So since we took the 12, right, 2, right, so we don't need 2 anymore. So we have to have only 1 over here. So to remove this 2, we will be dividing this x by 10. So x is equal to x by 10. So when you divide 12 by 10, you will have 1 in the x. So we'll be having 1 in our x. So now our reverse value is 2 and x value is 1 we have. Now as the next step, we have to store this 1 to reverse, right? We will proceed the same thing over here. So reverse is equal to 2 we have, and reverse is equal to reverse into 10. We have reverse into 10, right? So 2 into 10, which is 20 we will get, plus x modulo 10. So now why we are multiplying it by 10? Because previously 2 is in ones position, but we are just promoting it, or else you can just, we are just giving a high importance to it, like making from ones to tens. So we need to multiply it by 10. So now if you multiply it by 10, it becomes 20, and then x modulo 10, which is 1 modulo 10, will be equal to 1. So our answer will be 20 plus 1, which is equal to 21. It got reversed, right? So if you didn't multiply it by 10, so what happens now? The thing will be like, reverse will be like 2 and x modulo 10 will be 1. So 2 plus 1, it becomes 3. But we want it as 21. Since 2 was in our ones position in our main integer, and we are just promoting it from ones to tens, we have to multiply it by 10. And we have to sum it by x modulo 10. So now you can see our reverse has been 21. And that's it. We have to simply return this reverse based on the following conditions in our test cases. So now let's go to our LeetCode sheet. And yeah, this what this while loop logic says over here. we are gonna traverse this whole integer till greater than 0, and we are using this reverse is equal to reverse into 10 plus x modulo 10, and we are just removing the last digit by using x is equal to x by 10. So now next step is we are gonna check the sign, right? Because here in example 2 you can see x is equal to minus 1 to 3, they have like returning it as minus 3 to 1. So this is very simple. If not sign, if sign is equal to false, then not sign of false will be true, right? So if it's true, then it will enter into the if condition over here. If not sign, which is if the number is in negative, then we have to simply return minus 1 into the reverse value. But even here we should check a thing, because in our class thing we are returning integer function, not a long. Our reverse has been stored in long, right? But we have to return it as an integer function, so we have to convert this reverse into int. So we are converting this reverse into an integer from long to integer, and we are just multiplying with minus 1. So now let's return this, and if it is a positive number, no need of checking, right? So return, again you have to convert this into an integer and then reverse it. Return the reverse it over here. Okay, so first two conditions, first all the test cases have been done with it, but we have an statement over here. This assume the environment does not allow you to store 64-bit of integers. So we have to check whether the thing is exits 4 bytes or not, whether the integer exits 4 bytes or not. So we are gonna use a if condition over here inside of while loop itself. So if the reverse value, right? So after all this thing we have found the reverse, right? If reverse is greater than integer dot max value. Max value here is the greatest size bytes of a positive number. So if it's like greater than the integer's positive size, or else reverse is less than integer dot min value, which is like if the size of bytes is less than the integer's negative value size. So either if the reverse number is greater than the size of integer's positive, or else minimum than the size of negative numbers of integer, we have to simply return 0 in here. So let me explain this thing once again. So first we are just initializing a boolean variable sign, which is true, indicates the number is positive. And if the number is less than 0, which is if the number is in negative, then we have to change the sign value into false. So now we have assigned if a sign is true, we should consider the number is positive. If a sign is false, we should consume the number is as negative. So once we got this sign data, we will just make all the numbers into positive by using math.absolute function. Absolute function is a function which makes all the numbers into positive, simple mathematical function. So now we are initializing a reverse variable equal to 0 with long data type, and we are going to traverse whole integer from x greater than 0. And once the loop enters, we are using a formula called reverse is equal to reverse into 10 plus x mod 10, as I explained over here, same concept. And we are just using x is equal to x by 10 to remove the ones position from our main integer. And we are gonna check if the reverse is greater than integer or max value, which is greater than the 4 bytes of positive numbers, and or else like less size of the negative numbers, we are returning 0 as per this statement. If not, it's entering into other sign loop. If not sign, which indicates if the number is negative. If sign is equal to false, then not sign is equal to true, right? So if not sign, we are just seeing over here return is equal to like -1 into integer of reverse, because we are returning integer type over here, but our reverse thing is in long. So return is like -1 into integer of reverse. We are converting a reverse into integer and multiplying it -1 to make it as a negative number. And then at last we are just returning, if not, if it is a positive case, then we are returning just the number of the reverse, integer of reverse. So now let's run and check. Okay, well, good. Our test cases has been passed. Now let's submit and verify it. So yeah, our program has been successfully submitted, and that's it, guys. This is a very easy numerical. So that's it, guys, and stay tuned for the next LeetCode numerical, and thank you.